In Flutter, we always hear this sentence, everything is a widget. And yes, that is true. But if you stop there, Flutter still feels magical. You write some widgets, the screen changes, and somehow Flutter knows what to rebuild, what to keep, what to lay out, and what to paint. So in this video, we are going one level deeper. We are going to understand the three trees behind every Flutter UI: the widget tree, the element tree, and the render tree. Once these three trees are clear, Flutter topics like setState, BuildContext, keys, rebuilds, layout, and performance will become much easier to understand. Let's use one simple example for the whole video. Imagine we have a small profile card. It shows a name, a likes count, and a button. On the screen, the user only sees this, a card, the name Alice, the text likes 0, and a like button. This looks simple on the outside. But inside Flutter, this UI is handled through multiple layers. First, Flutter starts with the widget tree. The widget tree is the description of what we want to show. For our profile card, the widget tree might look like this. At the top, we have a profile card. Inside it, we have a column. Inside the column, we have a text widget for the name, another text widget for the likes count, and an elevated button for the like button. So the widget tree describes the structure of the UI. It tells Flutter what the UI should look like. But this tree is not the final pixels on the screen. It is more like a blueprint. A very important point is this: widgets are immutable. That means, once a widget object is created, Flutter does not edit that same widget object again and again. Instead, when something changes, Flutter creates a new widget description. For example, right now our text says likes 0. If the user taps the button, the likes value becomes 1. Flutter does not take the old text widget and directly change it. Instead, it creates a new text widget description, likes 1. This is why rebuilds in Flutter are normal. A rebuild does not automatically mean the whole screen is destroyed. It usually means Flutter is creating a new widget description and comparing it with what already exists underneath. And that brings us to the second tree, the element tree. If the widget tree is the blueprint, the element tree is the life structure of the app. An element represents a widget at a specific location in the tree. That location part is very important. For example, we can have many text widgets. One text widget shows the name, another text widget shows the likes count, and another text widget can be inside a button. They are all text widgets, but they are not the same place in the UI. The element tree gives each widget usage a real position and identity inside the running app. So when Flutter builds our profile card, the widget description is inflated into elements. The profile card widget gets a profile card element. The column widget gets a column element. Each text widget gets its own text element, and the button gets its own element. Now Flutter has something more stable to hold on to. Widgets may be recreated often, but elements are more persistent. They help Flutter answer important questions. Is this new widget replacing the old widget at the same location? Can I reuse the same state? Can I keep the same render object? Should I update this part or remove it and create a new one? This is why the element tree is so important. It connects the temporary widget descriptions to the live running app. So we can say, widget means description. Element means location, identity, and lifecycle. This is also where BuildContext starts to make sense. In Flutter, BuildContext is basically a handle to a location in the widget tree, and that location is represented by an element. So when you receive context inside a build method, you are not receiving a random object. You are receiving access to where this widget lives in the tree. That is why context can find ancestors like theme, middleware, navigator, provider, or an inherited widget. It searches from that location upward in the tree. So a simple way to remember it is, BuildContext is your access point to the element tree. So far we have two layers. The widget tree describes what we want. The element tree keeps the live identity and connects that description to the running app. But neither of these directly draws pixels. For drawing pixels, Flutter needs the third tree, the render tree. The render tree is made of render objects. Render objects handle the lower level visual work. They are responsible for layout, size, position, painting, and sometimes hit testing. For example, a text widget eventually needs something that can measure and paint text. A column needs something that knows how to arrange children vertically. A button needs render objects that define its size, shape, interaction area, and painting. So the render tree is where Flutter starts thinking about real geometry and pixels. Here is one detail many beginners miss. Not every widget creates a render object directly. Some widgets are only configuration or structure. For example, a stateless widget or stateful widget usually builds other widgets. They are useful, but they may not directly produce pixels by themselves. The render tree is usually smaller and more concrete than the widget tree. It focuses on things that need layout and painting. So now our mental model becomes clearer. Widget tree means what should the UI be? Element tree means where does each widget live and what can be reused? Render tree means how does this become layout, paint, and pixels? Now let's walk through what happens during the first build. Flutter starts with the widget description. It sees profile card. Profile card builds a column. The column has two text widgets and a button. As this description is created, Flutter mounts elements into the element tree. Each element holds the current widget configuration for that location. Then, for widgets that need rendering, elements create or update render objects. Those render objects enter the render tree. After that, Flutter performs layout. And after layout, Flutter paints the result on the screen. So, the first build flow is widget configuration, element mount, render object creation or update, layout, paint, pixels on screen. Layout in Flutter has one golden rule. Constraints go down. Sizes go up. Parent sets position. Let's understand this with our card. The parent says to the card, you can be this wide and this tall. Those constraints go down to the card. The card passes constraints to the column. The column passes constraints to the text and button. Then each child decides its size within those constraints. The text says, based on this font and this string, I need this much space. The button says, I need this much space. Those sizes go back up. Finally, the parent decides where each child should be placed. So the column says, first text goes here, second text goes below it, button goes below that. After layout is complete, Flutter can paint the final result. Now let's see what happens when the user taps the like button. The likes value changes from 0 to 1. We call setState. Many beginners think setState redraws the whole app, but that is not the best way to think about it. setState tells Flutter, something in this state changed. Please rebuild this part of the widget description. So Flutter calls build again for that part. A new widget tree description is created. The old widget description had likes 0. The new widget description has likes 1. But Flutter does not blindly throw everything away. It compares the new widgets with the old widgets at the same locations. If the type and key match, Flutter can update the existing element. This is where Flutter's matching rule becomes important. When Flutter compares an old widget with a new widget at the same location, it checks two main things. Do they have the same runtime type? And do they have the same key? If the type is the same and the key is the same, Flutter can update the existing element. For example, old widget likes 0, new widget likes 1. Both are text widgets. If their keys also match, Flutter reuses the same text element. Only the widget configuration changes. But if the type changes, Flutter cannot update the same element in the same way. For example, if the old widget is text and the new widget is icon, Flutter may need to remove the old element and create a new one. So the simple rule is, same type and same key means update, different type or different key means replace. Now this also explains why keys are so important, especially in lists. Imagine we have two profile cards. First card Alice, second card Bob. Now we reorder them. Bob moves to the top, Alice moves to the bottom. Without keys, Flutter usually matches widgets by type and position. At position 1, there was a profile card before. After the reorder, there is still a profile card at position 1. So Flutter may reuse the first element for the new first widget. For simple stateless UI, this may look fine. But if each card has its own state, animation, text input, checkbox value, or focus, then the wrong state can appear attached to the wrong data. This is where keys help. A key tells Flutter, do not only match by position, match this widget by identity. So if Alice has Alice's key and Bob has Bob's key, Flutter can move the correct element with the correct data. The important idea is this: keys are not mainly for widgets. Keys help Flutter match widgets to elements. Now let's connect this back to BuildContext one more time. When you call something like theme.ofContext, navigator.ofContext, or mediaQuery.ofContext, Flutter starts from that context location and looks upward. That is why the location of context matters. If you use a context that is above a provider, scaffold, navigator, or theme, Flutter may not find what you expect, because context is not just the current screen. It is a specific element location. So the simple memory line is: BuildContext is your access point to the element tree. Now let's go one level deeper into the render tree. The render tree is where Flutter thinks about geometry, not business logic, not app state. Geometry. How big should this be? Where should this child go? What should be painted? Should this object receive a tap? This is why layout errors are usually render level problems. When you see overflow errors, unbounded height problems, or constraint issues, the problem is usually connected to the render tree. For example, a child may ask for more space than the parent allows, or a widget may ask for infinite height when the parent expects a finite size. That is why the layout rule is so important. Constraints go down, sizes go up, parent sets position. Once you understand that, Flutter layout errors become much easier to debug.